Alright, let's get started. Now we'll be moving on to our next topic, which is the screw conveyors. And just like what we did, first discuss the overview, then we'll get to the parts and assemblies, and then after that, we'll get into the computation aspects. Okay, so now for the first part, screw conveyor basically transports the material from one place to another by the rotation of the screw. Okay, so the screw is there is a shaft, and then there's a helix. Okay, so once this shaft rotates, there is a tendency or an action to the material, or when the shaft rotates, it actually pushes the material to be transported, or something like this. Now, if you try to zoom in, what we'll see is a shaft, and there's a helix. Okay, so this shaft is it is typically a hollow shaft, but it is also possible to design it using a solid section. You see, that depends upon the design and situations. Okay, so because this shaft rotates, then it means that there's a power, or there's some source of power, so that it can drive the rotation. And there is an electric motor or gear motor. Okay, we'll just write gear motor, okay, or sometimes electric motor. And this electric motor or gear motor is connected to this shaft. Now, there are many types of drive configurations. So you can have a direct drive coupled or using chain and sprocket or belt and pulleys here. Okay, so if we draw it in 3D, what it will look like is something like this. So there is a pulley or sprocket, then there's a belt, and then this is our screw conveyor. Okay, so of course there must be some water mounts here connected, okay, to support this electric motor. Okay, now this gear motor is different from an electric motor. A gear motor is basically an electric motor plus a gearbox or gear reducer. Okay, so the main idea of this is this screw conveyor rotates at around, let's say, 50 to 150 RPM, and our electric motor rotates at around 1700 RPM. Okay, so around this value, and in order to reduce this RPM to 50 or 150, using a chain drive, I mean this single drive, whether chain drive or belt drives, you might not be able to reduce it to this value. So probably you'll do compound drive systems, multiple belts and pulleys. But you can actually obtain that by using a gear motor instead. Okay, so as I've said, a gear motor is an electric motor with a gear reducer, and this gear reducer has a ratio, let's say 1:10. If it's 1:10, instead of having 1700 RPM, probably the output here is 170 RPM. So from this value to this value, then you can actually provide the pulley combination or sprocket combination. Okay, so that's it. That's the construction of the drive systems. Okay, what else? Now in This entry point is what we call the inlet, and this one is the outlet, or referred to as the discharge end or discharge. This was the inlet. So the inlet can be connected to a hopper. Okay, so that is to accommodate much volume of materials compared to having without a hopper. Okay, what else? We have this enclosure. Okay, there's an enclosure or a casing that encloses this screw. This casing can be a U trough, meaning shaped like a letter U, or it can be cylindrical. Okay, so for example, this is our screw, the shaded circle here. So our casing can be a U shape called U trough, and this one is cylindrical. Okay, so in some situations wherein not much sealing is required, then the U trough would be the U trough can do the job. But if you require a seal, probably the material can be more viscous than, or more fluid, more fluid like. So you would need a proper seal. So this cylindrical totally enclosed case would do the job. Okay, so some designs or situations, the U trough can be provided with a cover, and this cover is fastened to this flange, this flange of the trough. Now, for longer length, now imagine that if we have a length that's long enough, then of course the deflection of the shaft would be significant, and hence there's going to be some kind of support called a hanger bearing. A hanger bearing. And at this end, okay, so in this end, there's also a bearing that supports the shaft. Okay, so if we try it here in 3D, so you can have a flange bearing or whatever bearing, I guess. It will also do the job. Okay, so this is our shaft. Okay, so this shaft, there is actually I think the term there is end shaft, because it is connected to the shaft of the screw, the pipe, by having this bolt, for example. Okay, so if we draw that in side view or section view, I guess, much better, it would look something like this. Okay, this is our end shaft, and it is connected to a bolt. Okay, so there's a bolt right here. Okay, we'll extend this end shaft. Okay, so that's the typical construction at this end portion. So that goes the same to this portion right here along the hanger bearing. Okay, so now let's go on to the nomenclature of the screw. This is the screw, and the distance from this bottom tip to this top tip is called the screw diameter. Okay, so we can just write D sub S, or sometimes I might write it like phi sub S, so that denotes a screw diameter. And this diameter of the shaft is called, we can denote symbol d sub p, meaning diameter of the pipe. Okay, so sometimes I just I I mean I refer to this as the as a shaft, or sometimes I refer to it as a pipe, because in some designs this shaft is actually a hollow section or made from pipe. Okay, so that's why the distance from this point to this point, that's what we call the pitch, okay, the screw pitch, denoted, or we use the symbol P, letters lowercase p. Now for the pitch, we have four types. We have a standard pitch, a short pitch, a half pitch, and what else? The long pitch. And also there are other type of pitches, like for example a variable pitch. But the difference is that when you say standard pitch, it means that the pitch distance is equal to the diameter. Okay, so meaning that if this is our diameter, then our distance would be the same. Okay, so this is our distance, I mean our diameter, and this pitch would be the same to the distance d. Now for a short pitch, we have a pitch that's equal to 2/3. Okay, so maybe something like this. So much narrow spacing. And for half pitch, as the name implies, it's just 1/2 of the diameter. So meaning you have a more narrow spacing. And for long pitch, of course, you have a greater than, I think this is 1.5 times the diameter. Okay, so meaning you have a wider spacing. Okay, so the application of this is, if you have a screw that is inclined, then there's going to be a loss in the capacity, and so a increased number of pitch. Okay, so increased number of pitch, or a short pitch distance, can actually compensate for that loss of loss in capacity. Okay, next we'll go on to the type of flights. Types of flights. This one is types of pitch. This one will be types of flights. Okay, let me write it clearly. Okay, flights. So there are flights that have special designs, but for the basic one, we have a standard flight. A standard flight looks like the one we already discussed. Okay, so something like this. So it's a plain helix. When we say ribbon flight, the helix is actually, there is some cut portion. Okay, so probably something like this. Okay, so it has some designs along the flight, and that's what we call as the ribbon flight. Now for cut flights, we have something like this. There's actually a cut portion somewhere along this flight, along this flight. Okay, and sometimes instead of just having it cut, sometimes it can be folded. Okay, so if there's a folding, then that's gonna be cut and fold, cut and fold flights. And there are also a type called as the paddle flights. Okay, so the application of this, you can actually read that in a manufacturer's catalog. For example, the ribbon flights, if you have a material that's viscous or sticky, then the ribbon flight can actually do the job. And probably if you want mixing, then you can go for a puddle flight. Okay, now let's move on to the properties of materials. Okay, so what are the properties that that affects the design of a screw conveyor? Okay, so number one is the bulk density. Of course, if you have if you have a heavier material, then of course you would need a larger power requirement. And also, since there's going to be a transport of material, there's actually motion of materials, then there's going to be an internal friction. Okay, so however, instead of going to the properties, there's another thing about this material that's referred as the material characteristics. And of course, it is also related to this, to the properties. Okay, so the first one would be the abrasiveness. There are materials that are abrasive, so meaning that if it is abrasive, then there's gonna be wear on the components, the material of the components. So if that's the case, then the screw conveyor must be designed properly. So it can be, for example, use a thicker screw or thicker materials, or you can just increase the diameter so that the material will not come in contact, or will not come into contact with the shaft. Okay, so those are just one ways. One way you can refer that to the manufacturer's catalog. Okay, so abrasiveness. Next one is friability. Friability refers to the characteristic of materials that, when slightly agitated, it crumbles. Okay, so some materials are friable, so meaning that if in this case of materials, then you would probably go for a lower speed, so you have to handle it with care, something like that. Okay, what else? You have hygroscopic properties. So some materials can readily absorb moisture. So that way, probably you can have effect on the flowability of the material. And also another one would be viscosity. Okay, so take note that viscosity, if you recall in your subject in fluid mechanics, that it's basically the resistance to flow. Okay, so it's harder to transport the material if it is viscous. Okay, so now let's go in the material code classification. Okay, so if you have access to link, about just have attached a link to a manufacturer's catalog, then you will notice that they classify the material um, in terms of some code. So that code, if you read that code, then you can actually obtain a lot of information. For example, the average density, size, abrasiveness, and other properties. Okay, so for example, um, going to the material manufacturer's catalog, we have this material characteristics table. In that table, you will see, for example, let's take a look at the shelled peanuts. So we have this weight, and that's actually density, pounds per volume. Then this one is the material code. So you'll see a code right here. For example, 18D3 36q, and it also tells the trough loading, the material factor, and other information. Now this material code, let's write it here. The first two digits, it is 18. Actually, that's the digits before this letter, this D sub 3. This is the density. It's actually the average density. So if you see 18, this one is 15 to 20. So meaning the density is given in range, and it's taking the average value. Okay, so for some materials, instead of range, you have a value right here. Okay, so if you see 30, this one is also 30. Okay, and the next one, the D sub 3, this refers to the size of the material. So the D sub 3 or C 1/2, or we can have B6, that refers to size. This one refers to, I think that's the flowability, and this one is the abrasiveness, and the last is what we call the miscellaneous properties. Okay, miscellaneous properties. Okay, so let's write it here. 18D3, that's 36q. Okay, this one is our density. This is the size, the D3. This is the flowability. This one is the abrasiveness. And Q is a miscellaneous properties. Now you would notice that for some materials, for example there's no miscellaneous properties. Okay, so where can we find the information regarding the size, flowability, and abrasiveness? Okay, so it's also tabulated, or it's also given in a table. For example, the size, we have D3. Okay, so you see this D3, then meaning that our material is a granular material, and that's 3 inches. The size is 3 inches and under. Okay, so for some materials, for example, you see a C 1/2, then that's gonna be 1/2 inch and under. For powdered products or fine products, then you would see this symbol A200, A100, so on. Okay, and it is also possible to have a material or convey a material in a screw conveyor that's larger than the granular size. They classify it as lumpy, over 16 inches to be specified. Or also it can be irregular, stringy, fibrous, whatever. Okay, so for the flowability, we have a code designation 1, 2, 3, 4. So if it is 1, then it means it is very free flowing. and if it is 4, then it is sluggish, meaning it cannot it's the opposite of this free flowing. For the abrasiveness, the code destination is 567. So if it is 5, it means it is mildly abrasive. It is 7 is extremely abrasive. Okay, so we have discussed this already, the abrasiveness. Then for the miscellaneous properties, we have these letters right here. So for example, if we have in an F, that builds up and hardens. Okay, so when the material is transported, it builds up and hardens. Okay, so meaning that you have to consider that in your design. Another one would be the hygroscopy. So if it is U, then that's the material is hygroscopic. Okay, so